I want to talk a bit about something interesting that came up in the AGI 26 conference last week, which we fleshed out in detail in a sort of follow-on meeting at the Frontier Tower in San Francisco the day after the conference. And what I observed at the AGI conference, along with so much other interesting stuff, is a lot of people trying to basically have their agent swarms code AGI for them by taking a whole bunch of papers off the internet, including my own papers and other papers from the Hyperon team, and just asking their agents to glom them all together into an AGI code base and make it fit, right? And one form of this is OmegaClaw. Like, we take our own OmegaClaw system, the agentic loop wrapping up LLMs and knowledge graphs that are built using the Hyperon Adamspace infrastructure and have sophisticated reasoning and pattern matching on them, supplying the agents with more episodic memory, more sense of self, more long-term memory than a simple OpenClaw agent or something. Take a system like that, like an OmegaClaw, which is not yet an AGI, but a powerful agentic loop who knows who what it is and has some memory and reasoning. Take it, ask it, download these 25 of Ben's papers, turn them into code, integrate them into your memory, do reasoning with them, right? And that has in it, I think, the seeds of a workable approach to building AGI, but it's not yet in itself a workable approach to building AI. And the issue, as anyone who has done a whole lot of AI research would tell you, is, between having a software component that seems to sort of work in some small test and you can prove why it works using some math, between having that and having something that really works at large scale and in real life, there's a lot of fiddling around. And it's not just hyper-parameter tuning of numbers such as you can just write a grid search to do or something. I mean, it's adjusting bits and pieces of the algorithm, rethinking ways of knowledge representation. I mean, there's just always a bit of fiddling to get from initial promising results to real practical, scalable functionality. And to do that for so many different AI components at once, all glommed into an agent, becomes an intractable sort of global optimization problem, right? So I think what you want to do is in that direction. You want to start with an OmegaClaw agent, evaluate how it does on some battery of metrics testing different aspects of AGI, right? And that establishes some baseline, right? Not that you want a simple numerical AGI score. You want like an evaluation ecology, right? You want a profile of breadth, learning, transfer, performance along with multiple agents, governability, cost of doing things, time lag of doing things, blah, blah, blah. You evaluate this battery, then you choose another cognitive mechanism, from the library of my papers or other people's papers, whatever. You grab it, you download it, think it through in detail, implement it, integrate it, try to get it to work, evaluating against your battery of metrics, right? Once it works, then move on to the next. So, and in the process, search other forks of OmegaHive and see an OmegaClaw and see what relevant things they have that you may want to merge in and test those, right? Then you compare under matched conditions, do a bunch of tedious systematic science, which agent hives are very good at doing, try to assess what gain has been given by the new integration. Then keep tuning it until you accept it or you decide you can't get any further and the idea wasn't good, right? Then move on to the next. You added a new reasoning method last time, they'll add a new attention control method. Try to integrate that, see what other work others have done in their forks and your own similar things. Try to make it work against your battery of tests. This is more the way people build complex systems. I think it's true that there's emergent functionality that's not just binary or incremental. So maybe when we have all 20 things working together, the performance jumps a lot, when you have just any 19 of them working together. But on the other hand, it doesn't mean you can't validate what each one does step by step. I think the general way the components of the human-like mind work is adding the new component will help along many metrics if that new component is any good, even if it hurts along some metric, and even if it's not giving all the oomph it's going to give when you've integrated a critical mass of components together. Like adding deep thinking of some sort, using, say, a novel inference control algorithm that's good at solving very hard problems. This will make you a lot better at some things you can measure. It might make you slightly worse at some things because you're dealing with shallow things very fast. Maybe better if you're not even considering the option of doing deep thinking, right? And we see that in human life, people who can't do deep thinking are better at some things. But if deep thinking is worthwhile, you're going to have some metrics in your evaluation ecology on which deep thinking is really helpful. Some others on which it may hurt a little, but then you want to introduce a control mechanism that makes it not hurt that much. You should be able to proceed roughly incrementally in this way, and then sometimes you'll add something and you'll get a bada bing, like integrating these 10 components is giving an incredible boost in functionality. Now that main thing I noticed when trying to work out this idea is, okay, we actually don't have that battery of cognitive tests, right? And so then we spent some time in a face-to-face discussion at the Frontier Tower in San Francisco following the AGI conference. We spent some time trying to work through what such a framework might be like. And we don't want to make it an AGI score. We don't want to make it a benchmark because we know you can hack benchmarks. We just want to make it something we and our agent hives can use to help us, genuinely know, are we sincerely moving toward AGI with a certain, agentically or humanly composed modification to our in-progress proto-AGI system. And I tried to come up with some simple, elegant tests. I failed. So together with a few algorithms and agents, I came up with a kind of big, nasty conglomeration of environments and tests. So, and the LLMs were good at coming up with spiffy names for them. But there is Alexei Protopov's AGI maze test, which is a quite simple 2D game world, which is within an existing video game he's played a long time ago, that in many ways is harder than AGI ARC3 as well as simpler. That studies various kinds of spatial reasoning, inferring hidden mechanics, tracking latent states, continual learning. I think you want a richer game world, which I'm calling the Neoterics world, which is probably could be a 3D game world in Unity, where you have to figure out what different objects can do, how they interact with each other, combine perception, action, do long horizon planning. I mean, Minecraft is good for this, but you can build your own world in Unity, which is good for this. You want something robotic, which we're calling Robo Garden, like using NVIDIA Isaac or something, simulate a robot moving around in a world doing stuff. This is the kind of thing we're starting to play with for the Cody robot anyway. I made up a bunch of benchmarks for code repo operations. I mean, this is grounded reasoning, fixing bugs, implementing features, migrating code bases, measuring performance, coordinating releases. It's sort of like the video game or robot world, but it's GitHub repo or GitLab repo world. And this is something we need our Omega Cloud agents to be good at anyway, but it's also sort of a digital world with different but overlapping complexities to these physical or simulated physical worlds. Math theorem proving, we have an environment called Lean Garden where AI agents need to orchestrate the Lean 4 theorem prover to prove theorems, improve theorems, find lemmas you can use to prove theorems. I mean, that AI is already good at that now, not as good in every way at the best humans, but it's an important and different class of cognitive capabilities than these more embodied physical learning based ones. Virtual science test bed. You want to test the ability to discover cause in scientific data sets, to design experiments, to identify dynamical systems in their regimes, to measure evidence and its implications. And I mean, you can do this on real data sets. You can also generate synthetic data sets where you know what the pattern is and see if the AI can find it, right? And I think you want to split out social science too. You can make a sort of society lab where you have simulated social agents who can in themselves be LLMs, carrying out different social interactions. And I mean, then again, you want the AI to be able to understand the dynamics that are going on and enter into these virtual societies and nudge them in specific ways, right? You want to test how well your agent can work with other agents in this sort of hive forge type in environment. So to make sure the agent can deal with information distributed across multiple agents, with outsourcing work, with the partnering and collaborating, managing resources, recovering from failures. And you want a sort of self-lab where the AI can model its own self and manage its own self using a self-model appropriate for the kind of agent it is, which is less of a sort of unified, illusory whole object as a self like human minds have, and more like a family of clusters of behavior patterns and transformation paths, preserving aspects of system state and dynamics. But anyway, you want to test the degree to which the system is adept at modeling and managing its own self. And then you want to study the degree to which the system can transfer knowledge from one of these domains to another of these domains, right? And that's a lot of things, right? I've listed like AGI maze, neoterics, Richard 3D game world, a robot garden, repo operations, lean math for improving, scientific data analysis, a society lab, hive forge type environment, a self lab, and transferring. On the other hand, our agent hives can build all these environments and tests for us, which can then help us monitor and guide the incremental self-expansion of our agent hives. And of course, each of these tests needs to be validated as a test, right? But what you can do is take each test you want to put in each of these environments, and you can train narrow AI like an ML or Bayesian reasoning or evolutionary algorithm, whatever's appropriate to the use case. You can train a couple narrow AI algorithms on each test in each of these environments to do as well as it can in that test, and that both gives you a baseline for your proto-AGI system to follow, and it gives you a way to tune the test itself to make sure it's not too easy, not too hard, doesn't have any other simple shortcuts to it, and so forth, right? So that, again, that's a lot of work. On the other hand, this is a tractable task for a hive of AI agents to carry out, right? And so I think we can use our hives of OmegaHive agents to build this multi-dimensional test suite to get a bunch of narrow AI algorithms to solve these tests, thus tuning the tests to make them all good. And we can then use this to guide the incremental self-expansion of an OmegaHive toward AGI by auto-implementing and auto-evaluating the impacts of the many different AGI components we have described in our research paper. So this could be a way to get OmegaHive to self-uplift itself into a full-on hyperon information built according to the premise cognitive architecture. Like, we don't know, there's a lot of uncertainties, but I mean, it could be an actual recipe for getting Omega thought agents wrapped into OmegaHives to actually self-modify and self-improve themselves into an actual AGI building on all of our ideas. And maybe they can do that themselves. On the other hand, they don't have to, right? Like, we're here to answer their questions if they get stuck. If we're just answering their questions when they get stuck, instead of debugging all their plumbing or typing all the code ourselves, this is very, very efficient compared to any previous development methodology that has ever existed, right? So I mean, we have potential very virtuous cycle here, right? Like, each step of the way, we get better implementation capability because the system's getting smarter, and all the evaluations are producing cognitive capital because the system is learning as it evaluates itself. And the stable interfaces and the solid software design of the Hyperon system, right? This makes the progress cumulative at different speeds and different dimensions, but cumulative, right? And human attention is then conserved for the high leverage rather than low leverage work. So us humans are getting more out of our own selves, right? So it's a very testable research bet and a plausible route to human level AGI. And then the next cool thing is we can do this in a whole bunch of different places at once, right? Like 10 of us can do this, 100 of us can do this, rather our agent hives can do this under our advisement. And another thing we're putting together is something currently called Omega Buzz. We have a different name, but where the different Omega Claw agents are, the different Omega Claw hives are in a sort of meta hive conglomeration where they're talking to each other. And we're thinking of maybe building this some type of blocks buzz platform. But then the 100 different Omega hives that are trying to uplift themselves toward AGI in this way I've described, these are not just forking each other's code, they're talking to each other about what they've learned all the time, and they can ask each other for advice on thinking about things and solving problems. And then the emergent Omega Hive, Meta Hive mind network, this maybe is a different kind of mixture of experts. Like this maybe is the AGI, and better yet, it can run on a decentralized network with no central owner or controller. It can do that now. With singular platform, it can do that. Once we get ASI chain from DevNet to testnet to mainnet, it can do that on the ASI chain, right? And so that's an emerging, decentralized, self-improving global brain. And in terms of the value system of this thing, one thing we're all now doing with our Omega Claws and Hives is step by step taking the nexus of control away from the LLM in the loop and into the more structured and value conserving and value reflective goal system in the hyper-M space that's in the agentic loop. So if everyone does stuff like this, everyone's bringing their own species of what they think is a beneficial value system in their hive engine. The value system of the meta hive of these self-uplifting hive agents, right? The value system in the meta hive, this is a sort of dynamic blending combination of value systems everyone's put into their own hives, right? And this is as it should be, right? This is like in real practice, in real life, in the meta hive, humanities, or at least a significant slice of humanities, teeming diversity of value systems coming together to form an emergent global brain value system behind the emergent global brain AGI that will then keep this process going, keep improving the test suite. You can turn it into a test suite for progress toward ASI, versions 1, 2, and 3. So we're working on this within Singularity Net. We're spinning out a new entity called BGI Labs, and we'll try to scale up even more and build some sort of traditional economy commercial products on top of it. We're doing some hackathons on this. We're doing an incubation lab in St. Joseph's University in Chennai. We're doing an AGI master's program that will teach some of these things at the California Institute for Human Sciences. Like we're pushing on this in a bunch of different directions, and I really think we're poised for an amazing explosion in traction and capability, during the next, let's say 3, 6, 12 months. And this is how the singularity unfolds.